Hello students, welcome to the chapter derivatives of the functions. So in this video I am going to discuss standard functions derivatives using formula and rules of the derivative. Just to understand how to use the rule and formula to the examples, I am doing this video. So first, recall the derivatives of some standard functions. The first standard function is x raised to n function. So this function derivative, that is d by dx of x raised to n, is given by or written as n into x raised to n minus 1. Okay, so remember how to write the derivatives of x raised to n into x raised to n minus 1. So x raised to n functions means like x square, x cube, x raised to 10, or it may be any fraction, x raised to 3 by 2, x raised to 2 by 3, x raised to 4 by 3, such type of function derivative is followed using this formula n into x raised to n minus 1. And it is very simple, the power of x, that is n, that we have to take, and x raised to minus 1 you have to do it. Okay, so this is the way of writing derivative for this type of functions. And second one is d by dx of 1 upon x raised to n. There is a difference between x raised to n and 1 upon x raised to n. So if I find derivative of this function, then the derivative is minus n divided by x raised to n plus 1. Okay, directly this gives a derivative answer, minus n, that is power, divided by x raised to, now here increase 1. Okay, for example, if we have a 1 upon x raised to 5, 1 upon x raised to 5 function, derivative of this function is given by minus 5 divided by x raised to 6. Okay, you have to increase here, that is the answer. Okay, next is d by dx of k, where k is constant function. So this function derivative always 0. Okay, where k is constant. So next is trigonometric functions derivatives. So you know there are 6 trigonometric functions, that functions derivative, what we get. So that I am going to discuss now. D by dx of sin x. So derivative of sin x function is written as or given by cos x. Okay, and d by dx of cos x is given by minus sin x. D by dx of tan x is given by secant square x. D by dx of cot x is minus cosec square x. D by dx of secant x is secant x into tan x. D by dx of cosec x is minus cosec x into cot x. So these are trigonometric functions standard and their derivatives. So next is rules of the derivatives. So remember there are 5 rules we have. You have to remember. The first one is d by dx of k into f of x, where k is any non-zero constant. So if any constant is multiplied to the function, if any function multiplied by constant like 2 sin x, 3x cube, okay, 3 is multiplied to x cube, or 2 is multiplied to sin x. So in this case we say that 2 is multiplied to the function, 2 is not separate. Okay, so in that case the derivative is written or followed like this: k outside, only d by dx of f of x, means only function you have to differentiate, that constant we should not differentiate. Okay, so next is d by dx of sum of two function, f of x plus g of x. So f of x plus g of x, if you have, then derivative is given by d by dx of f of x plus d by dx of g of x. It is very simple. Separate individually, you differentiate the functions. Similarly for negative, d by dx of f of x minus g of x. Okay, it is given by d by dx of f of x minus d by dx of g of x. Fourth one, d by dx of f of x into g of x. So this is very important, product. Okay, so this rule is different, not like the addition and subtraction. Okay, the rule is very simple and very important also. So product of two function derivative is given by g of x into d by dx of f of x plus f of x into d by dx of g of x. Okay, it is very simple. Keep one function as it is, g. Differentiate the first one and keep the first one as it is, differentiate second one. Okay, alternative. So this is a formula, and this formula is called as a product rule. Next is a division. How to write the derivatives of division of two functions, f of x divided by g of x. So rule is given by g of x, that is denominator, d by dx of f of x minus f of x into d by dx of g of x whole divided by g of x whole square of the g function. So this is the formula. Okay, it is also very simple. Understand in this way, denominator function g as it is, d by dx means derivative of the f means numerator function, minus, so be careful students, this is minus middle, f of x, that is numerator as it is, derivative of denominator, that is g, and whole divided by square of the denominator function. So this formula is called as quotient rule. So whenever the question is given, you have to identify the function, whether it is an addition, subtraction, product, or a k into f of x. So first identify that, follow the rule, and then write the derivatives of the functions. Okay, so I hope you understood all these formulas and rules of the derivatives. Okay, now see the solutions, how I am using these formulas, derivatives to the examples now. Okay, first I will solve simple examples. If you understand that one, definitely will do it difficulty examples. First you have to understand how to use the rules and regulations. Okay, so before that, just remember some standard functions derivatives. D by dx of x function, d by dx of x function is 1, remember. Okay, if I follow that n into x raised to n minus 1, no, I will get the answer is 1. So every time it is not required to follow that rule. So if you remember x function derivative is what, it is directly write the answer. And second one is d by dx of x square. So if I again follow that x raised to n formula, I will get answer 2x answer. Okay, so remember x square function derivative is 2x. Third one is root x. So this is also standard function, root x, remember. So root x function derivative is 1 upon 2 root x. So these are the three important functions and their derivatives. Don't forget these answers. Okay, now I take examples. Find the derivative of the function y is equal to 5x raised to 4 plus 3x square minus 2x plus 10 equal to, plus 10 with respect to x function. So y function is given, find the derivative of that function with respect to x variable. So here with respect to x variable is given means the function is written in x variable, therefore with respect to x variable. If the function is with respect to, if the function is given by in terms of t variable, then here it is given with respect to t variable. Okay, now see the solution. So first write a given function 5x raised to 4 plus 3x square minus 2x plus 10, and then differentiate with respect to differentiate y with respect to x, we get. Okay, now here I am recalling that formula. Here for this example I am using x raised to n formula, following this n into x raised to n minus 1 and k into f of x, because here you can see that the some functions are multiplied by numbers like 5x raised to 4. X raised to 4 function, for that 5 multiplied. X square is a function, for that 3 is multiplied. X is a single function, that is multiplied, and all these are in addition and subtraction form. As is given in the rule, if we have a addition or subtraction, individually you have to differentiate functions. Okay, so now let me write derivative now. And one more point, students, whenever you write a derivative right side, some students you will not write left side dy by dx. Directly you will writing equal, and right side you are writing derivative. That is also meaningless. So that is not the way of writing the answer. First left side dy by dx, then equal to, then right side derivatives. Okay, so 5 as it is, differentiation of x raised to 4. For that I am using this k into f of x, plus 3 as it is d by dx of x square, minus as it is 2 as it is d by dx of x. Now last term it is only 10. This is not multiplied by any x variable, therefore that also you have to differentiate. Okay, so here also we have constant, here also we have, but the difference is this is multiplied by some function variable function, these constants, but this is not multiplied by any x variable, therefore this we have to differentiate. I hope you got it. Constant function, how to identify. Okay, next is writing the derivatives of x raised to 4, that is 4x cube, and x square derivative is 2x, x derivative is 1, and constant is 0. So next is a simplification of this step, that is 5 into 4 20, 20x cube plus 6x minus 2. Okay, let me continue. Next example, find the derivative of the function with respect to x. Y is equal to 4x cube minus 3x, 3 into 1 upon x square, plus 2 by 5 1 upon x raised to 5 minus 1. So y function is this. So now see the solution. Given that y function, okay, now differentiate with respect to x. Okay, now in this example just I am giving you formula 1 upon x raised to n formula. It is given by minus n divided by x raised to n plus 1, and k into f of x is used as a k into d by dx of f of x. So this is the formula used for this example. 1 up x raised to n, and also x raised to n also is there, already I discussed. Okay, now see how we get dy by dx. Derivative equal to 4 as it is x cube function derivative minus 3 as it is derivative of 1 upon x square, plus 2 by 5 as it is 1 upon x raised to 5 derivative minus derivative of 1, because it is a constant function. Okay, next is writing the derivatives of the functions. X cube function derivative 4 as it is, x cube function derivative is 3x square, minus 3 as it is. Okay, now minus 2 divided by x raised to 3. So I am using here minus 2 divided by x cube, this formula, plus 2 by 5 as it is, x raised to 5 minus 5 divided by x raised to 5 plus 1 becomes 6 and derivative of 1 is 0. So next is a simplification. So in this simplification, here you can see that 5 and 5 get cancelled. Okay, so now write derivative of dy by dx is equal to 4 into 3 is 12x square, minus into minus become plus. Okay, multiplying this 3 into 2 6, and this plus into minus become minus 2 divided by x raised to 6. So this is the derivative of the given function. Okay, next example, find the derivative of the function with respect to x. Y is equal to 5 sin x plus 3 cos x. Now I am taking trigonometric functions and algebraic combination. Addition example only, addition and subtraction, and k into f of x form examples. Okay, so first write given function and then write differentiate y with respect to x. Okay, so directly here I am writing a derivative of the function. 5 as it is sin x function derivative plus 3 into derivative of cos x minus 2 as it is derivative of cot x and d by dx of x cube plus d by dx of a. Okay, so first always whenever the question is given, whether it is addition or subtraction or product, you have to identify. Now in this example we have only addition and subtraction. Okay, now I write derivative of sin x, 5 as it is derivative of cos x, 3 as it is d by dx of cos x is minus sin x. Here you can see that I substitute. Now when you write the answer here, you should not write d by dx. Answer itself is a minus sin x. Okay, otherwise again what happens if you write here d by dx, again you have to write the derivative of this function. Already you written answer of this, it is minus sin x. d by dx of cot x means minus cos x square x answer. Okay, d by dx of x cube is 3x square, and a is a independent of x variable, therefore answer is 0. Okay, so next is a simplification. 5 cos x minus 3 sin x minus into minus, it become 2 cos x square x, and this is 3x square. So this is the answer of the given example. See, all these are simple examples, but here you have to understand how to write the answer, how to follow the rules and derivatives of the functions. To understand this, I am solving these examples. Okay, next go for next example. If y is equal to x cube minus 2x square plus 3 into 5 tan x plus 5 secant x plus 1. Now here only you can see that while reading only you will get the idea whether the given example is product form or addition form. It is a combination. Okay, it is a product of two function. In that only we have addition and subtraction. Okay, if y is equal to this function, then find dy by dx. Okay, so first always you write, start with the given example, that is y, and then write differentiate y with respect to x. Okay, now here directly don't differentiate, x cube is 3x square, and this, see the question, it is a product form, into we have. So therefore recall that formula, d by dx of f of x into g of x. It is given by g of x as it is derivative of f plus f into d by dx of g. Okay, now here, now I select one function as f, that is first one I select as a x, f of x, and second one I select as a g, that is 5 tan x plus secant x plus 1. Now I follow this formula. dy by dx is given by formula g function as it is. That is 5 tan x plus secant x plus 1. Put the bracket for that. Into dy by dx of f function, that is x cube minus 2x square plus 3 plus f as it is, that is x cube minus 2x square plus 3 derivative of g function. Okay, so this is according to rule, the derivative is written. Next, wherever you have d by dx, see here we have d by dx of this function, and in next d by dx of this. Write the derivatives, that is the answer. Okay, next step, 5 tan x plus secant x plus 1 as it is. Now I am writing derivative of this bracket function, the derivative of x cube. Now this is subtraction and addition form. Individually you write a derivative, like x cube individually, x square individually, 3 individually. Okay, so d by dx of x cube is 3x square minus 2 as it is, x square is 2x and 3 is 0. X square derivative is 2x. This 2 we keep as it is. This one we should not differentiate. 3 derivative is 0. Okay, I hope you understood. So next go for plus x cube minus 2x square plus 3 as it is. So now write the derivative of this trigonometric function, that is bracket function, 5 tan x plus secant x plus 1. Now 5 as it is, tan x derivative is secant square x plus secant x derivative is secant x into tan x plus 1 derivative is 0. So next rewriting this function. So bracket here we can simplify, but not required because all terms are different. So therefore just rewrite the function. So first bracket as it is 5 tan x plus secant x plus 1, and in the second bracket 3x square minus 4x, because 2 into 2 4 and 0 not required to write, and then plus x cube minus 2x square plus 3 as it is. Here 5 secant square plus secant x into tan x plus 0. So this is the answer. So this is the way of writing following the rules and regulations. Product means product rule. Okay, addition means addition. If next example, if y is equal to x square plus 1 into, here you can say that while reading only you will get the idea whether it is into or separate. X square plus 1 into sin x plus 3x minus 5. Okay, here we have product. This is product. That means when you are writing differentiation of this product, you have to follow the product rule. And plus 3x, it is a single 3x, minus 5 separate. Okay, so then find dy by dx. Okay, so first you write a given function y is equal to x square plus 1 sin x plus 3x minus 5, and differentiate y with respect to x. Okay, now here see, first for this product we have to use product rule. Okay, dy by dx equal to, now product rule is what? Keep one function as it is, that is sin x or any one. Okay, so it is not compulsory the g, f, and in any manner you can follow that rule. So first keep one function as it is, differentiate sin x plus, now sin x you have to keep as it is, a differentiation of that is x square plus 1. Okay, so this entire is become now derivative of the product, plus 3 as it is, d by dx of x, and minus minus d by dx of 5. Okay, so this become derivative of that given example. Next is writing the derivative. X square plus 1 as it is, d by dx of sin x is cos x, sin x as it is, derivative of x square is 2x and 1 is 0, and 3 as it is, derivative of x is 1 and the derivative of 5 is 0. Okay, next is rewriting this answer, that is x square plus 1 into cos x. This become 2x sin x or sin x into 2x, and this is plus 3. 0 is not required to write. So this is the solution of the example. Okay, I hope you understood how to follow the rules. Okay, identification is very important. When you read the question, you have to get the idea like it is a product. Okay, it is a separate of addition, subtraction. If you get that idea, easily you can write the derivatives of the functions. So now let me take a example on division. If y is equal to 3x square plus 2x minus 5 divided by sin x minus cos x. Here only you can say that divided by. Okay, so that means you have to use quotient rule. Okay, first write a given example and then differentiate y with respect to x. We get, okay, now here I am recalling that quotient rule, d by dx of f of x divided by g of x. Okay, it is given by g of x into d by dx of f of x minus f of x d by dx of g of x whole divided by gx square. dy by dx, okay, denominator is what? Sin x minus cos x. First you write that one. Okay, so derivative is given by sin x minus cos x, that is denominator, into d by dx of numerator, that is 3x square plus 2x minus 5, and minus numerator as it is d by dx of denominator, that is sin x minus cos x, and whole divided by square of the denominator function. So that is written as bracket sin x minus cos x whole square. So don't write individually square like sin square and cos square. Whatever the function we get in the denominator, put the bracket for that. Okay, and then write the square. This is the way of writing that denominator term. So next is writing the derivatives. So dy by dx is equal to numerator sin x minus cos x as it is, 3 as it is, x square derivative is 2x. Okay, so this is k into f of x. 3 as it is, x square is 2x, and then 2 as it is, x derivative 1, 5 derivative is 0, minus 3 as it is, 3x square plus 2x minus 5 as it is, d by dx of sin x is cos x and cos x is minus sin x, and whole divided by square as it is. Okay, here we don't have any differentiation denominator, it is just squaring. Okay, next rewriting the function, that is a sin x minus cos x, 3 into 2 is a 6x and 2 into 1 is 2, 0 not required, minus 3x square plus 2x minus 5 as it is, and here cos x minus into minus become plus sin x divided by sin x minus cos x whole square. So this is the way of using division rule. I hope you understood how to use this formula. So now let me take one more example on division. If y is equal to x square sin x divided by x plus 1, then find dy by dx. Okay, So first write always given function, then write differentiate y with respect to x. Okay, here I am not recalling that formula directly, I am following that formula. Dy by dx is equal to, denominator is x plus 1. No, write first x plus 1 using the bracket, because it is not single function, it is a addition x plus 1. So write for using bracket, you write x plus 1, then write d by dx of x square sin x minus x square sin x as it is d by dx of x plus 1, and divided by x plus 1 whole square. So this is rule. Next is wherever you have derivative, you write it. Okay, now see here we have d by dx of x square into sin x. So if you read function, you will get the idea whether it is into or addition. Okay, it is into, therefore here the product rule is followed. The product rule is keep one function as it is sin x, differentiate the second any one function, that is x square, plus now x square as it is d by dx of sin x. Okay, changing one time x square derivative, one time sin x derivative, and keep the remaining other function as it is. Okay, that is the rule. And use the bracket here because when you follow the rule, we have a addition in the rule, therefore put the square bracket and write the formula. Okay, or write the answer, minus x square sin x as it is, and d by dx of x is 1, and d by dx of 1 is 0. Okay, and whole divided by x plus 1 whole square as it is. Next step is writing again derivative in that product rule, x plus 1 as it is, d by dx of x square is 2x and sin x is cos x, and the remaining as it is x square sin x into 1 whole divided by x plus 1 whole square. So further simplification is left to you students, you can do it, otherwise you can stop the answer. Here just my intention is to how to follow the rules and regulations, that is important. Simplification is for particular example, you can do it. Okay, thank you very much.